Dear colleagues, my name is Anastasia Ilina. I am a research assistant of the Laboratory of Molecular Mechanisms of Aging at the St. Petersburg Institute of Bioregulation and Gerontology. I am a PhD student of the Department of General Pathology and Pathological Physiology at the St. Petersburg Institute of Experimental Medicine. Today I'd like to focus on the first part of the physiological aspects of the application of short peptides under hypoxia conditions. In particular, we will discuss hypokinesia and exhaustive physical activity. It should be noted that the development of modern society is characterized by widespread phenomena of limitation of general motor activity named as hypokinesia, as well as excess nutrition, neuroemotional stress, which affects individual and population health. An important component of the hypokinesia is oxygen deficiency, that's hypoxia, which is characterized by an insufficient supply of oxygen to the body tissues or a violation of its use at the molecular level. It's important to point out that due to reduced overall motor activity, hypokinesia contributes to premature aging and is one of the symptoms of age-associated neurodegenerative disease. Improving physical working capacity in hypokinesia and general physical endurance is a subject of physiology in various professional groups, including in extreme activities. By this reason, scientific search, evaluation, and testing of individual substances and compositions effective in relation to working capacity represent an independent direction of research in this field. Today, we are talking about the EDR peptide named as pinealone, that is an active component of the dietary supplement Cellutin. The drug cortexine was developed based on a polypeptide complex obtained from the extract of the cerebral cortex of young calves. The dietary supplement Cellutin was developed based on a polypeptide complex obtained from the extract of the whole cerebral cortex with white matter. The pinealone peptide was synthesized based on analysis of amino acid composition of polypeptide complex from the extract of the cerebral cortex of young calves. First of all, let's talk about assessment of animal physical working capacity under the exhaustive physical activity. The outbred male Wistar rats aged 5 months was used in the present study. Exhaustive physical activity was simulated by running on a treadmill with an electrically conductive grid until failure. The experiment was stopped when the animal behaved passively when in contact with the electric grid 3 times. This model allows us to determine the real reverse capability of the organisms. The study consisted of several stages. The background values of physical performance were determined in the first stage of the experiment. After 3 days, the following drugs were administered: metaphor and EDR peptide. The relative value of physical working capacity was determined daily after administration of the drugs. The following results were obtained in the study of the effect of the EDR peptide on the physical working capacity of the Wistar rats by running on a treadmill before failure. The peak of the physical working capacity of rats was noted during the 7th, 10th day of metaphor administration. The dynamic was greater in rats injected by metaphor than EDR peptide. The physical working capacity decreased when metaphor was consumed. The physical performance of the control group has gradually increased as they exercise. The performance of animals injected by the EDR peptide grew faster, doubling by the end of the first series of experiments. Unlike metaphor, no withdrawal syndromes was observed in rats injected by the EDR peptide. It should be noted that introduction of the EDR peptide leads to a more persistent improvement in the physical working capacity in rats, which did not stop after the abolition, unlike animals receiving metaphor. On the 5th and 10th day after administration of the drugs and evaluation of performance in rats, hematological and biochemical indicators have been determined. So let's look at how the hematological indicators have been changing in rats under the exhaustive physical activity. All hematological indicators were decreasing in rats injected with drugs as opposed to control. Changes in hematological indicators were minimal in vivar control rats, not exceeding the limits of the standard values for animals of the species. The observed blood dynamics were reliable and maximum on the 10th day after the EDR peptide administration. There is an adaptive character of hematological indicator dynamics. Change in these indicators correlate with the duration of daily physical activity regardless of the metaphor or EDR peptide. Now let's look at how the biochemical indicators have been changing in rats under the exhaustive physical activity. The creatine kinase activity was decreasing both in the EDR peptide group and in the metaphor group. The decreased activity of this enzyme was more pronounced in rats injected with EDR peptide than the metaphor, and accompanied by a 12% decrease in magnesium ion concentration. Taking into account the decrease in blood glucose level, a decrease in creatine kinase activity during the introduction of metaphor compared to the background values indicates that energy supply has switched to the path of glucose utilization. Lactate levels in rats with chronic metaphor during the physical activity were increased to almost 6.5. Similar trend was observed in rats injected with EDR peptide. Submaximum physical activity of rats injected with drugs does not significantly deplete the receipts of creatine in the blood, since energy is generated not due to the reaction catalyzed by the creatine kinase, but due to the process of glucose utilization. Increased level of lactate suggests a significant role for the anaerobic component of the energy metabolism. Given the similarity in physical working activity in animals due to both metaphor and EDR peptide, as well as the same type of change in the studied hematological and biochemical parameters, it's believed that EDR peptide, as well as metaphor, is a nectoprotector. In conclusion, it should be pointed out that the EDR peptide, as an active component of the complex dietary supplement cellulotan, is an effective actoprotector and is appropriate to be used in order to increase reserve capacity of the human body in exhaustive physical activity, as well as to improve physical working capacity in hypokinesia. That's all I have to discuss in the present lecture. So, thank you for your attention.